Hello, my name is Michael McCabe, Product Manager for RFID at Pepperl+Fuchs. Welcome to part 3 of this series on RFID and IO-Link. In this video, I'm going to walk through almost every row of the Diagnostics and Configuration tabs. When looking at the web interface for the first time, the sheer amount of data can be overwhelming. Hopefully by watching this video, you'll realize that the data is laid out quite nicely, and it's not hard to find what you're looking for. First up, the Diagnostics tab. Just know that no matter what device you attach to the IO-Link master, the general layout of the diagnostic data will be the same. And this is true for the Configuration tab as well. Now this screen will update about every 15 seconds, and you can see you have options to control this in the upper right hand corner. Also, you can reset the statistics. For example, if a process data error occurs, you can use the Reset Statistics button to place it back to 0 once you've addressed the issue. As a side note, I've made my screen bigger so that you can more easily see what I'm talking about. This is what it looks like in full view. Notice that you have access to all 8 ports on the ICE2 IO-Link master. Alright, next up, again we notice that each port has its own column. So we see port name, which you can change over on the Configuration tab if you'd like. Just know that the port name will stay the same even if you attach a different device to it. And real quick, I should note that some of what appears in the Diagnostics tab are just settings that can be chosen in the Configuration tab. Alright, so this port is set up for the attached device to communicate via an IO-Link signal, as opposed to a digital in or digital out signal. You'll often come across the nomenclature SIO, which stands for Standard Input Output. As mentioned before, an RFID head can't be a digital in or digital out device because it reads and writes data. It's not a simple true or false signal. It actually carries information. Now, a standard ultrasonic sensor could operate as a standard input-output device, operating as true or false. And if so, it would likely say digital in here instead of IO-Link. Again, you can change this on the Configuration tab. And if this were to say reset, it means you've probably disabled this port. Next, we see that the port is operational, and the process data input is valid, even though we haven't read a tag yet. IO-Link state is listed as operate, which means that the port is functioning correctly in IO-Link mode. You can see on the screen that there are a lot of other options for the IO-Link state. Next, pretty self-explanatory. Pepperl+Fuchs is the vendor. Here is the model number specified by the vendor, and below is the serial number. This is all correct. Alright, so now we see that the IO-Link version is 1.1, and I know this is correct because I can verify it against the datasheet or the product manual. As of January 2017, all new devices made need to be version 1.1. The older and original version is 1.01. Version 1.1 allows more storage, faster communication, and the ability to store parameter settings. Our ICE blocks are version 1.1, and they work with devices from either version. Next is actual cycle time. This is the actual or current cycle time of the connected IO-Link device. In this case, my RFID head. This is what it's actually operating at. Device minimum cycle time is the minimum or fastest the IO-Link device could be. And last, we see configured minimum cycle time. This is basically the fastest that the port can operate at. Alright, so moving along as I scroll down, here I see data storage capable is listed as yes. This means that my device is capable of data storage. So, what does that mean? Well, let's imagine that I have 8 RFID read heads, and I'd like to connect them all to this ICE2 block. With this feature, which started being offered in version 1.1, I can configure one RFID head, save the settings to the ICE2 block, and then send those settings out to the remaining 7 RFID heads. Configuration is that easy. So basically, with this feature enabled, the port can automatically upload data from the IO-Link device and/or download data from the IO-Link master. Remember though that not all devices are capable of doing data storage. Again, the automatic data storage configuration can be set on the Configuration tab. Depending on what you set, this field may either say upload, download, or both. Now here we see the auxiliary input bit status. This is basically pin 2, mentioned in the previous video. If you remember, a device may have additional functionality utilizing pin 2. So if your device is connected to digital in pin 2, verify that this field displays on. Now these next 3 rows cover the process data input. So for instance, how many bytes does our connected read head allow? Device PDI data length says it right here, 32 bytes of data are available. And we see that the current status of the PDI data as received from the IO link device is valid. And below, I not only see that the IO link master regards this data as valid, but you can literally see all the data below. Count and you'll see 32 bytes of data, represented in hex form, which is just a different way to show a number. Now, if you are unsure what hex means, you can go online, type in hex to decimal calculator, and then convert the hex number to a base 10 number, which you're used to seeing. By using a hex system, we can express a larger number with only 2 digits. Now, as a side note, in this video series, I'll be operating this RFID head in easy mode. This allows up to 28 bytes of usable data, which is true here, even though we're seeing 32 bytes. It turns out that the first 4 bytes of information are actually just some data that describes what's going on. For instance, this 04 is just telling me that a task is active. And I know this is true because, as shown in the last video, the blue light on the RFID head is currently lit. I'll go into more detail about all of this in a later video. And now let's talk about PDO, or Process Data Output. PDO lock enable just make sure that if a PLC is currently controlling the IO link setup, nobody comes in and changes a setting that they shouldn't, using the web interface for example, which if done could cause damage or worse to the machines. Here, you see yes, this feature is available, but PDO locked says no, so we're not currently locked out from making any changes. The process data output info on these next 3 lines are similar to the process data input already discussed above. And next we see time since initialization. So if I remove and then plug my RFID head back in, or repower up my ICE2 IO link master, the time since initialization will go back to 0. Now, so far I've got no process data errors. But since I just removed the IO link device while the master was trying to communicate, I can now see a number showing in the process data retries. Underneath that, I can even see the total number of events with descriptions which occurred, mostly due to my actions. Now, when speaking about IO link and RFID, you'll primarily be concerned with process data, which is cyclic data, and service data, or ISDUs. And this is true for most sensors. Now, some manufacturers might provide more useful information here in the event section, but generally, you might not need to pay much attention to these. These events may cover things that are less severe than something like a whole device failure. So now, let's look at the ISDU statistics section. Now, when you're actually setting up your device, you'll probably not only see some events that trigger, as mentioned above, but you'll probably also see some ISDU statistics jump up as well. And after the sensor is connected, I recommend clicking on the Reset Statistics button that's shown at the top. This will help clear out events and stats that were triggered by the setup. Now, a real quick note on ISDU statistics. Don't be surprised if over time you see some of these increase slightly. There are background processes going on which act like a heartbeat, validating certain parts of the device. They'll increase too when you initiate ISDU commands, which I'll talk about in a later video. And next, let's go and review the Configuration tab. First thing to know, by clicking on Edit, you can change the different options which are available to you. Once done, simply click Save. Now, when I discussed the Diagnostics tab, I talked about port name, port mode, and PDO lock enable. So for right now, I'm going to skip over them. Just know that this is where you can edit them. Again, SIO stands for Standard Input Output. When I connect a standard non-IO-Link sensor, or if I'm using an IO-Link sensor simply as a standard input-output signal, if I make this true and choose to invert this signal, if pin 4, the QC pin, normally sends a high signal, it will now send a low signal instead, and vice versa. This is similar to the invert auxiliary input option shown below, which refers to pin 2, which is sometimes used for additional functionality. By now, you're starting to see that there's a lot of options, but you may not need all of them. It really just depends on your application, what you have to change around. For instance, next we'll see default digital output, and we'll only use this if you've set up your port as a digital output. The on-off options will help you configure the output voltage, either 0 or 24 volts. You can see above, I've set the port mode to IO link, so this currently isn't relevant to me. Next, we see the minimum cycle time, which lets us configure how often data will be sent between our device and the IO link master, the default value being every 4 milliseconds. You can program this anywhere from 4 milliseconds up to 538 milliseconds. If you do leave the minimum cycle time set to the default value, the IO link master will negotiate with the IO link device for its minimum cycle time. And you can see this on the Diagnostics page displayed as the actual cycle time. Alright, so these next 4 settings allow me to basically set up 2 different ways of processing my data. 1, for an input to be valid, the input needs to be present for the time specified under input settling time. Notice you have options for both the auxiliary input and the SIO signal. And 2, once I have a valid input, the IO link master should keep a hold of that value or data for the specified input hold time. Again, this is just giving us more flexibility with how we interact with our data. So next is data storage configuration. First, realize that data storage relates to the device settings which are actually stored on the device itself. In this case, my RFID head. The configurations on this screen are for the port, which is on the IO link master. If I remove my RFID head from port 1 and replace it with an ultrasonic sensor, these settings won't change because port 1 didn't change. I just connected something different to it. Data storage simply indicates whether a port should upload or download a device's settings, and whether or not to do this automatically. You either upload to the IO link master or download to the connected IO link device. The vendor and device IDs do need to match. Automatic uploads and downloads will occur when you adjust device configurations. And yes, there are some small differences between automatic and manual. It'll just depend on your application which will work best. So, for example, my device is already attached to port 1. So I'll click Edit, then manually upload the device configuration to the ICE2 IO link master. I'll click Continue, and now we can see that the device ID is shown. This helps indicate that the device data has been uploaded to the IO link master. And to show you how to do this automatically, I'll go to port 2 and click Edit. I'll set it up for auto upload. Now watch what happens as I remove my RFID head from port 1 and place it onto port 2. There is now device data on port 2, and once I refresh the screen, it shows that it's been uploaded. Easy as that. And as a side note, don't turn on both automatic upload and automatic download. You'll likely get mixed results between different manufacturers. And if the upload-download buttons aren't displayed, your device may be older than version 1.1, and data storage may not be an option. So by this point, you should start to see how easy it is to replace a defective IO link device, or configure multiple devices with the same set of parameters. Alright, we're moving on down to validation configuration, the last section here on the configuration tab. So what if a company is required to only use Pepperl+Fuchs RFID heads as some sort of specification guidelines? Can they ensure that a port will only accept a Pepperl+Fuchs product? Of course. Through device and data validation, you decide if the port will accept a device based on what you specify. For example, let's imagine that I only want a device similar to the current RFID head that's attached. I'll click Get Attached to automatically pull and populate its information. So first we'll look at device validation mode. For the compatible option, the vendor ID and the device ID need to match. For the identical option, the device's serial number also needs to match. For data configuration, loose means that PDI and PDO lengths must be equal to or less than the bytes specified. And you guessed it, that strict means the bytes must line up perfectly. And now I'm not going to go over this next part too in depth, but I'll click on Load Save, and then we see that there are options to both save and load configurations for the IO-Link master, data storage, and IODD files. And lastly, since I did change some settings that I don't want to keep, I'm going to click on Clear Settings. I don't have an IODD file uploaded yet, so I'll select IO-Link data storage and click Clear Configuration. Now, if I go back to IO-Link under the Configuration tab, everything here has gone back to the default settings. Alright, so in the next video, we're going to head over to the Attached Devices tab, and I'll show you what an IODD file is, where to get it, and how to upload it. Again, my name is Michael McCabe, Product Manager for RFID at Pepperl+Fuchs. And as always, remember that Pepperl+Fuchs is a leader in industrial automation. So click the subscribe button below to see the new industry-leading products that we come out with. And if I did a good job on this video, please click that thumbs up button so others can find it more easily. Remember, if we don't tell YouTube what's important by giving it a thumbs up, we're going to keep seeing only those shocking and crazy videos, which can be fun, but they're not helping us to become the intelligent professionals that we aspire to be. Thanks, and I'll see you next time.